Hi guys, welcome to Learn Electronics Repair. We've all seen this before and its siblings, by the way, so if you watched the previous videos, the other two went back and they were working. This one is the one that blew up. So we have some faulty parts on this. I think these are the bad ones actually. Let's have a look. A couple of IFPFZHDO MOSFETs. Yeah, short. And then we have another MOSFET here, 23N20D. Short. Okay, so they're both short. This has one of these little insulating heat transfer pads on. There's another one in here, so I've obviously disconnected something else from this. Don't quite remember because it's been waiting for parts. Oh, I have another little bag here. Okay, so here is another one, probably another one of those. Yep, 23N20D. Short. So that's why there's two of these little pads. We have two of these little, they're like SpongeBob SquarePants condoms, I think. That's the best I can say. These things fit over these, and then these are held down with like a springy clip. So let's replace these parts, including the SpongeBob condoms, yeah, and let's see if it works. So I have here, I bought a pack of 10, AliExpress. Yeah, came in a plastic bag, by the way. Okay. These are the replacements. Let's have a look. Get them into the middle of the shot there. Well, kind of in the middle to like that. So these are the replacements. Again, FB23N20D. So we can check some of those with the component analyzer. I have some more parts here. I'll just move all these screws and SpongeBob's out of the way. Okay. Yeah, we have these. So these are the replacements for the IFPFZHDOs. Markings like somewhat different from the original, if that has any context in this. Yeah, these actually look more original than those do. How about the other ones? How do they compare? So this is a bad one and this is one of the good ones. Again, the markings are different. Okay. And finally, I have some of these. So this one was the driver for one of these pairs. When I was tracking the thing through, I figured out that one of these pairs, I don't remember which, but we'll find out, had this driver and it was connected directly to it. So I decided that is quite likely faulty as well. Whereas the other ones were driven through a little transformer, I think. So they were isolated from the control and probably they were okay. Right, so that's what we've got. Quick walk down memory lane there to figure out what we were doing. Let's have a look. So we have 3 PCBs on here. This is the mixer or input section. One of these is the amplifier, class D, and the other one is the power supply. So I think this one was the amplifier, but it shouldn't be too difficult to figure out which ones went where. So let's start with this first. Okay, this is the power supply board. This is where the IRF MOSFETs go down there. This is where the SpongeBobs go as well. Yeah. So we'll just check a couple of these MOSFETs, just to make sure they are what they should be, which is N-channel MOSFETs. Okay. Yeah, N-channel MOSFET. So the drain is the center pin. Okay. Gate, drain, source. Other one. Go again with the same order. Test. N-channel MOSFET. So again, green is the gate, drain, source. So the drain is the center pin. Now, for whatever reason in the past, I've ordered MOSFETs from AliExpress or eBay and found that the ones they sent me don't match the actual pin out of the device I want to replace, although the part number is the same. The drain and source is reversed, and I have actually, in the past, the first time I saw that, it took me quite some time to figure out what the problem was. And I actually managed to cobble it, so I reversed the pins, drain and source, and it actually worked, the amplifier did. So I don't know what they sent me. It was apparently the right rating, but it just had a different pin out. Comment if you've ever come across that, but I have. So I want to make sure this is the right way round. Now, I don't have any good ones on here to test with. I could look up a data sheet, I guess, but we can work this out. So this has two capacitors which are wired in series. I'm sure they are. Yeah, wired in series there. Yeah, minus the plus. So this is the positive end here. And we can see that goes to the positive end of the bridge rectifier. And that should go to the drain of one of these. These are in series. That one. So drain to positive, which is correct. And then the source of this one, which is here, should go to the drain of the other one, which it does. And then the source of that one should go back to the negative end of the bridge rectifier, which it does. So I'm certain that they are the right pin out at least. Let's fit these and then we'll get on to replacing the parts on the other board. This is the driver for this one, SG3525A. I'm sure I have these anyway if I need. And that is the little transformer that sits between the gates and the IC, which is why I believe any high voltage when these went short were isolated from the driver by that. Okay, but I do have those chips if I need. Right, let's get a couple of these fitted. I generally find it's easier to mount the things in position first and then solder them. So there we are. I'll just tighten this up a little bit. Okay, then I will solder the components into position and then we'll just finally tighten them up a little bit more. So that's the way I find it's generally easier to do this. Be nice and level, or level enough. Of course, this heatsink compound is getting a bit everywhere. I'll put a little bit of fresh on when I've finished. Okay. Now I'll just tighten the bracket up properly. Straighten it up a little bit. Okay, so that's those mounted. Clean this up. Right, let's replace the other ones on the other board. So this one is going to be rather trickier because you can see that the devices have to match up with the holes in the heatsink here. Okay, that's where these white pads go. You can see two more over here. The problem is that I have to take the board off so I can solder them. Yeah, and I need to get them the right height so that the hole lines up to go through there. Yeah, I mean, talk about making this more difficult than it needs to be. I think at least we can say that the two devices which are already on here, which go here, are they in line with those? Yeah, they're all in line with each other, so that gives us some indication on here how to position them. That's the one good thing about this, okay? I think maybe if I clear the holes and I cut the legs on the new ones to match the length of the legs on those, if they don't just match already, let's have a look. No, mine are a bit longer. So if I get them to the same length as those, it might not be as difficult as it seems. Okay. Let's see if we can get this solder cleaned using the braid, otherwise it has to be the vacuum. The soldering tool on this one. Okay. Add a little ready solder. Try. Yeah, that's partially clear, but I'm not sure I'm easily going to get the component leg through. It looks sort of alright. Let's try it. Some extra flux is going to help. It's not doing a bad job actually. Okay, let's see. Well, that one goes easily enough. Yeah, they both do. Right. Let's test a couple of these, and again, let's see if we can figure out if it's the correct pin out. Okay. N channel MOSFET. Again, the drain is in the center. Well, on this one, the other two MOSFETs are the same device, 23N20D. I'm not sure I can get the pin out in circuit. I'll have a quick look, otherwise I can just unsolder one and check. Sometimes you can do this in circuit, sometimes you can't. Yeah, can't. Okay. Seeing as I have one, just quickly unsolder it. Okay. Is it the same? Well, actually it reads bad anyway, so that's 3 of them bad. Good job I did that. Let's do the 4th one. 23N20D. What we got? Bad. So this is the one with the MOSFET drivers, IRS2092S. Okay, over here, same. I did track this out on the previous video. This basically goes directly into these. That resistor looks a little bit suspect. Do we have the same components on the other side in the matching position? Let's have a look. I'm hoping one end goes to the chip on a certain pin and then I can work out. Yeah, it does. Goes down there. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Goes to 11 and 12 actually. That's not power or ground, is it? What's the resistor read? About 35 ohms. Let's look on this side. So that's mounted the other way up, basically. Okay, so 9, 10, 11 and 12, or 11 and 12 connected together on this one. No, they're not. Okay. And does that go to a resistor here somewhere? Try pin 11. Well, I don't see the equivalent position. I can see that the track here goes to pin 12. Yeah, you can see the track. Yeah. So on this one, pin 12, 9, 10, 11, that goes to a resistor over here. Okay. Yeah, and this is it a 100 ohm resistor? No, it wouldn't be, sorry. It'd be a 10 ohms. So it's either like 1, 0 and no more zeros, 10. I think that's a 10 ohm resistor. Reads 10 ohms. And it goes to a capacitor as well, we can see that. So from pin 12, goes to the end of a capacitor, goes to this 10 ohm resistor, and on mine, pin 12 goes to one end of the resistor. The resistor reads about 35 ohms. So a capacitor connected to this end. I mean, I'm expecting that this circuit is going to be the same on both. Is that the capacitor? Yeah, it goes to that capacitor there. So maybe just the layout's a bit different. So R60 and C42. R41, C32. And there's like an 8.2K just above the capacitor, which I think I saw the same on the other side. Reads 2.3K in circuit. And yeah, I think that's the equivalent one there, basically. And that also reads 2.3K in circuit. Okay, so why do we have a short between pins 11 and 12 on this one? Yeah, you can't see the meter, but you can hear it, yeah? Interesting. I mean, I suspected this chip anyway. This resistor is definitely going to be faulty. So let's remove both of the chips. In fact, let's have a quick look at the data sheet and see what pins 11 and 12 are, just out of interest. Then let's remove both of the chips, and then let's probe around on both and see, first of all, if that short has gone when we take the chip off, and secondly, if I can find any other difference if I'm reading across resistors on this side to the other side. Okay, so the chip itself is a protected digital audio amplifier. Okay, class D in a 16-pin package. We can see a typical application. So we seem to have a short. In fact, we do have a short from the low side MOSFET drive gate, LO. Yeah, that's probably the resistor that reads bad. And the short is from there to VCC, which is the supply to this chip. Okay, I think that's what it is, VCC. We have a VSS as well. Yeah, look, this shows 10 ohm resistors in there. Our circuit is almost certainly the same as this. Okay, VCC is the low side fixed supply voltage. Okay, VSS floating input negative supply voltage. There's a high side floating output voltage. Okay, high side floating supply voltage. So there's a number of supply voltages here, VS and VSS, VCC, V ground. Okay, I did notice, and I pointed out on the previous video on this, that I did have some floating low voltage supply on this, isolated from the main high voltage supply, which on this is this B plus and B minus. This is saying plus and minus 35. You can see that. Okay, so we have a short from one of these outs to the VCC. Right, so let's take the chips both off, and then let's see if we can find this short. I think we can be confident that these 10 ohm resistors are the ones we're looking at, and one of them is now reading 35, that one, which is very much in line with what's happened with the short and the MOSFET. The other pair of MOSFETs, because there's two of these amplifiers basically here in the bridge, I think. Yeah, this comes from a subwoofer, so I'm sure it's a bridge. So the other pair is in the other amplifier, and they look like they're faulty, but they're not short exactly. Okay, let's get these chips removed. This I'm going to do with hot air, and I sincerely hope they're not glued down. In fact, you know, actually, I think I might just cut all the pins on this one if I can, and then just remove the body, then remove the pins, because I'm sure the chip's faulty. I'm going to replace it anyway. Let's just see though if we can remove this simply with hot air. As often, I'm kind of like 6 of one and half a dozen of the other. When I'm doing these jobs, I kind of like work out on the fly what I'm going to do in any given situation. I think that's quite normal for this sort of work, to be honest. I don't think it's glued down, but the fact I've got all these close by capacitors and things, I think I may. Let's just see if we can remove the body and then take the pins off the board. Let's have a look how well this works. I mean, you have to be a bit careful with this, because if you put too much strain on, you might actually break the pad. Okay, not coming easily that way. Just going this way. I think I need some new cutters actually. Let's see if these are any better. Yeah, this is not going to go easily with this SMD. How best to do it? Hot air it is. Don't want to melt that, don't want to explode that. Okay. I'll put a bit of tape over these actually. Just want to keep that away from there so I can actually get heat into where I want it to go. Just try again. Get further out. Okay. Right. Let's see. What happens will happen, okay? What will be will be. Come on. Board sliding around. Put something behind it. Off. Looks like I actually left behind the legs that I'd cut off there. Okay. Looks like I didn't actually dislodge anything else. That's probably because the leaded solder I added to this caused those pads to melt faster, yeah, before the unleaded stuff could actually melt. Go for the other one. I'm not so convinced this one is faulty, but hey, might as well replace them both. And anyway, to get any sensible readings comparing between the two amplifiers, I need to take this off anyway, otherwise I can't really do a comparison on the nearby components. Okay. Again, we had some leaded solder. I'll try to protect the capacitor and the trimmer pot. Okay. Let's see if we can do this one as well without dislodging anything nearby. I'll just get into a direction where it's easiest for me to work because I'm right-handed. Okay. I don't think this thing will explode, but okay, who knows? Okay, while this is warm I might as well just clean these pads up a little bit. Sorry guys, out of shot, but it's done. Let's try and get this one in shot. This one will be cool now, so it might be a bit more difficult. I may have to just warm the area up a little bit, again with hot air, but let's just see. No, came nice and clean, other side. Make sure you've got the solder melted before you drag the braid, yeah? That's another way of taking pads off the board quite easily. Right, multimeter on ohms range, so you won't hear anything, but let's have a look. So, first thing then, do I still have a short between pin 11 and 12? 9, 10, 11. This is difficult without stereo vision. No, I don't have. Meter's working. Good. So that was in the chip. Yeah, so definitely defective chip. Now, this we know reads 33. And that one here is marked. So this is a 10. Reads 10. This one reads 513. I think that says 51k. Reads about 35 and it's climbing up. 52, 51. Yeah, so it settles at about 51. That's good. This one, 3741. That's a 37.4. Let's see. So that's a 3.74k. Very close, exact. 3.714. Okay. 6.041. These probably set something like the gain. That's why they're just close tolerance. It's a 10k. It's 10 near enough. Another 10 ohm. No, sorry, 100 ohm 101. Reads very close. This is a 10 ohm. Reads 10 ohm. It's a 10. That one is another 10 ohm. And that's reading 8.5k. Okay, so that one is bad. And this goes up here onto the chip again somewhere. A bit of ISO, clean it up a little bit so we can see a bit better what we have. Okay, so that 10 ohm, that one, I think this one read okay. Yeah, that one reads okay. And this one doesn't read okay. Yeah, 8.5k, and that goes up to here. So this is pin 1. Let's have a quick look on the data sheet again. What's this pin? VAA. Interestingly, on this typical application, I do not see a resistor, anything like that value there, but that's what it is. This is supply via 2.7k. And that capacitor smoothing, this is ground. Okay. But we can say it reads faulty. Okay. So that's that one. That one. Just carry on going round. This is 470 ohm, 47 and 10. Reads, yeah, 0.459k. Yeah, very close. This one, 4121, so 4.11k. That's basically spot on. 5761, so 5.76k. Spot on. This is at 8.2k. Which actually reads lower than that, but you'll find this in circuit sometimes. I'll compare that with one on the other side. Okay, it settles about 5.25, 3.3k. Well, I see a capacitor charging, and then back down here, this was the other 10 ohm. Okay, so that's all those probed. Let's do the resistors on the other side, and then we'll just come back and check the diodes. I know this is a bit laborious, guys, but if you don't do this, you're likely to just blow up the components you've replaced, because these are driving these MOSFETs. So 10 ohms. No, 100 ohms, sorry, 101, and that reads 98 ohms. Let's come down this side and work our way over. So I didn't get as far down on the other one. Reads about 1k, so 1k resistor. 4121, so 4.12, spot on. 10 ohm, spot on. Another 10 ohm. That reads bad. Okay, this one reads bad. Another one. Oh, was that the one that reads bad? I put the mark on the wrong ones. Yeah, that one's okay. It's this one that's bad. Okay. Easy done. Well, for me anyway. That permanent marker isn't so permanent. Okay, so this is the bad one. The fact, if you think it's strange that the 10 ohm resistors are the ones are reading bad, that is quite reasonable to expect, because the low value resistors is where the most current will flow if something's gone wrong. Okay, so those are by far the most likely to go anyway. 5.76 spot on. 3.3. This is where we had the 8.2 and they both went about 2.75. Let's have a look. 2.75. 5.25. Double check. 2.75. 5.25. Yeah, okay. Read the same. I'm happy. I'll just check these big resistors as well. These big power resistors. Because obviously some current flows this way. So let's have a look. So this should be 2K. Yeah, it basically is. This one, 4.64. Okay. Sorry. 46.4K. Yeah, pretty much spot on. Another one of these 10 ohm. Reads okay. .74 reading 3.6, 3.7, yeah. 6.041, yeah. 10K. 10 ohm, yeah, good. 51K. Good. So, one bad resistor on this side. Can you see now why you need to do this, or even though it's laborious? Can you see why? I hope so. Diode junction. This looks like a diode that way round. Diode junction. Diode the other way. Diode junction. Yeah. 3 diodes. Over to this side. We've got the 2 big resistors. In fact, we don't actually no, we're in diode mode. Let's do the diodes first. So wrong way round. Diode junction. Diode junction. There's a third one somewhere. Yeah, this one. Diode junction. 2K. Yeah, and 46.4K. Very close. Okay. Only other thing I can maybe just check is around some of these capacitors. I can't really test them, but what I do know is that I shouldn't have shorts across any of them. Yeah, there shouldn't be a short across any of them. Doesn't read short. Doesn't read short. There's lots of small capacitors. I didn't see any shorts around the resistors. There probably isn't. One more down here in this area. Let's have a look. Doesn't read short. Same on the other side. Meter's working. Doesn't read short. Doesn't read short. And this one doesn't read short. Okay, so we have 3 resistors, all 10 ohm, and we have to replace the chips and then the MOSFETs. Well, the MOSFETs were easy enough. I mean, I've cleaned the holes, so as long as I can get them cut to the right length, should fit on to the heatsink properly. These look like 0805. Yeah, I've got some here. I think that's the right size. So 0805 is quite easy to solder SMD. If you've not done SMD before, you want to practice, I'd probably suggest you try this size first. I can do down to 0402 quite comfortably. 0201 are a bit of a challenge, but I can if I have to. So there's some replacements. Normally with these, I'll buy a whole pack from AliExpress, so you get like so many of each value, 80 different values, whatever there are. And then if I start using one commonly, I'll just buy 50 or 100 of that value, just top them up. I mean, most values I probably never use, or very rarely, but some I might use more commonly, like maybe 10 ohm for example. So if I use a whole strip of these, I'll then order more of that value, just keep more of that value in. Same with the through-hole resistors as well, do exactly the same way. So here's our replacement resistor. You see these are, I mean, they are quite small, but they're not tiny, okay? Is that the same size? Let's have a look. Compare it with that one. Yeah, I'd say they're the same. So that's the size 0805. Yeah, look at that. Okay, so this is the right size. It didn't go very far, by the way, it's just there. So unsoldering and soldering these is quite easy. I do it with this with a nice big tip, but you might find a bent conical tip is good for this as well. Okay, with a bent conical you can probably more easily get to both ends at once, which is what I really want to do. So we'll add a bit of solder. Okay. Okay. And then see if we can just take this off the board. So I'll come at an angle where I'm not going to hit that other capacitor. Yeah, you see that's off, that's easy, yeah. So take a bit of flux. Clean one of the pads. Now I'm right-handed, so I can turn this board to any angle. I want to hold the resistor, the new one, with my right hand. So I'm going to clean one of the pads. That one. I'm going to turn the board this way round, and then I'm going to slide the new resistor into that solder that I've left on the other pad, okay? So here's my resistor. I'm going to get the soldering line in my left hand. I just want to flatten this down so it's sitting properly against the board. Just use the first thing that comes to hand to do it, which is a plastic thing, okay? That's flat. I'm going to melt the solder from the other side, try not to hit the trimmer pot. I'm going to slide the resistor into the solder. Okay? That's got one end of it. Now I'm going to take a little bit of fresh solder on the tip. You notice that time I only used the solder that was already on the board, okay? A little bit of fresh solder. And I'm holding it again because otherwise it'll probably unsolder and go missing. So again, just slide in. And that's got the other end. Now, what I'd often do now is take something like this, try and hold the resistor so it's flat, push down against the board slightly and just warm up both ends. Okay, shall we try it? And that should be nice and flat against the board. Actually, I have a nasty bit of solder there. Just deal with it. Even with a lot of practice, guys, this doesn't always go to plan. Stick plenty of flux on top of it. Again, just get hold of it. Soldering iron. That's better. Okay. It looks alright, this one on this side, but anyway. There. So that one's changed. We can measure it. 10 ohms, good. We'll go on to the other one and then we'll clean all the flux off in one go afterwards. So, same technique. This one's a little bit awkward because I have this capacitor. So I'm going to try and clean this pad and leave solder on that one basically. Let's have a go. Just get at an angle again where I can actually use it. Not a capacitor, a diode by the way. But it's still in the way. Okay. Unsoldered. Clean this pad. Yeah. New one. Okay, I have it flat. Can I get in here with this? If not, I'll use a finer soldering iron on this one. Let's see, so can I just get in here? Yeah, I can. Not exactly quite straight, that one, but I think it'll be fine. Wrong one. Okay. Just check. 10 ohm. 10 ohm. Put a bit of flux on that. I'll just clean up a little bit messy that one now. Okay, no problem though. I'll just move that a bit to get the camera to focus on what I want. Okay. Better. Right. If anything, the chips are actually easier than the resistors because they're a bit bigger, basically. Yeah, they have more legs, but let's see. So, remembering to go opposite way rounds on this board, okay? So, we have a dot here, which is pin 1. We have a notch here. So, pin 1 is here. The dot and the notch basically at the same end, okay? I need to get this at an angle where I can work again with it. Line it up. Now you'll come to the point where effectively you wish you'd left it alone. So just get it something like, okay, you can always adjust it slightly. Now we need to add a bit of flux, a bit of fresh solder, so we get a bit of flux on here, on this corner. I'm basically going to tag down one pin first, one corner. If it moves, I'll slide it back into position. So once again, a little bit of solder on the end of the tip. If I get a solder bridge, I'm not going to worry too much about that. I'll deal with it afterwards. I just want to get this thing held down. You can use a tweezers, or you might be better off with something like this. guys, practice and just find some way that works well for you, okay? So obviously it's going to move around a little bit. Push that on it. Now I've got that held on it, I can actually probably just take the tweezers and just effectively move it back where I want it, you see? Okay. Maybe slightly down that side, like so. Okay, and then we're going to come in and we're going to solder this pin. So there's a little bit of solder on the end of the tip. And there should be enough. In fact, I've got 2 pins. Okay, 3. So you can see that's now tagged down. And now we just solder all the rest of the pins. I'll go for this corner next. I like to go for opposite corners. Make sure I put plenty of flux on this. And that should hopefully stop the solder bridging from the pins clogging between them. This will help it to keep flowing how I want it. Okay. Once again, you can use a finer tip if it suits you. I'll kind of say, don't do it the way that I do it if it doesn't work for you. And don't tell me not to do it this way if you do it some other way. Okay, like, that's fair enough, yeah. We'll go with that one. You see I've got a solder bridge there, don't worry about that. Clean the tip off. I've got no solder on here now. You see I've cleared it. The flux helps mostly with this. A little bit tight in here with this tip, but let's see. I could get the finer one. I have one right ready to go if I want to use it, but personally I think this will probably do the job. Again, I have a solder bridge, so I've just wiped the tip. Yeah, still there. Don't worry. Come in again. Gone. And then we have just down here. There's going to be a bit of solder on the tip now from that one I've just cleared, so maybe I can use it, maybe I can't. Maybe I need just sort of touch more. I'm kind of using like the bottom edge of this. If you see what I'm doing, I'm using that bottom edge like a narrow tip, but with a lot of heat capacity, a big lump of metal behind it. Yeah. Told you the chips were easier than the resistors, didn't I? Dissolve the flux with the ISO and then mop it up with a bit of kitchen roll because it's going to be all over the board. Okay, there. Yeah, 9 out of 10. What do you think? Other one, well, you've seen me do it once, so I'll just do this the same way. I've just soldered one end. I will show you. So I've just soldered that pin and it's moved slightly, so you'll see that I can just flex this a little bit while the end's soldered down. I have a little bit of solder on the end of the tip, and that gets the chip nice and straight. And now I've done that, I can solder the rest quite easily. Okay, you see I'm using that sharp corner effectively as a fine tip. Okay. A little bit more solder when it stops working, just add a touch more. Okay. Want to just a little bit more now, you can see it isn't working anymore. If I get too much, it'll just cause a bridge probably. Again, just a touch more. Just struggling to get into that gap there a little bit. Okay, all done, no bridges that time. And it looks good. These trimmer pots, I may have to adjust these because I've changed the chips. At the moment I don't know what they do. Maybe the datasheet will tell me with a better luck, but for now I'll just leave them as they are. Now I need to just fit the MOSFETs, and I'm replacing all 4 of them with new. I've tested the new ones so I know they're actually good. I'm just going to use the old ones to effectively figure out what length I need to cut the pins to, and then they should fit in okay. To fit these, I've cut the leg to the same length as the other ones. I'm just going to solder the middle pin and see if I can line them up with the holes in the heatsink. If I have to adjust them, it's going to be easier while only one pin is soldered, and if they all line up okay, I can just come back and solder the other ones. That's the theory, at least. Take quite a bit of solder on the end of the tip. Okay. So again, just insert it, solder one pin. That one's slightly leaning over, I think, so I'll just try and straighten it a little bit. Okay. And I can bend them slightly. So these are particularly nasty to do because, well, basically they don't line up easily. You can't line them up and then solder them afterwards, is what I would normally do. I think this might be easier actually to stick the pads on there first. Thinking about it, because that's how the other ones are. This is where the little temperature thermocouple goes. I have all the hardware here, so this is one of the nuts from the previous ones. You see we have these little insulators on here, so I need 4 of those. I'll put a couple of, or at least one of the bolts in here to hold it in place. This is a right pain in the ass, this, guys. They could have designed this in many ways that would be easier than this, I am sure. Okay, let's see. Well, yeah, that lines up. Yeah, you can see it. But obviously, once I solder the other legs, I can't do this with it. I need to get it right. Okay. And once I do get it right, I need to take it off and solder them. That one's okay. This one's just bent over a little bit. Not flat. Oh, I see what's happened with this one. The thing slid downwards. Okay. I'll have to solder them and see if they're going to be close enough. Fingers crossed. Well, this is either easier than I thought it was going to be, or I must be luckier than I thought I was, because so far I have 3 out of 4. So I'm going to do the last one on camera, and let's see. Oh, I can't even put that in the way, so let's see without any magnification on this one. I was using my bench magnifier before. Does this one go? Well, yes, it fits into the hole. I've got this stuff all over me, by the way. I'll wash my hands when I finish this. Okay. It's the heatsink compound, or pigeon shit as we call this. White stuff back in the day. Okay. So, just want tightening up, but they're all on. So you'll see that each one has the white pad behind, both insulating and heat conducting, and then there's a little like top hat shaped thing that goes into the hole so that it effectively insulates the metal tab from the bolt that's coming through. Do not forget to put these things on, guys. And no problem with these, but if you're using, and no problem with these big thick white pads, but if the device has those like clear mica washers, check with your multimeter that you have no short from the tab to the heatsink. I'll do it anyway, but I don't see how that can happen with this type of construction. But those mica washers, sometimes you can puncture, and the same with like the little thin pink or grey ones that you find, like a rubbery type silicone sort of material. Because again, if you get a puncture through the washer, you've got a short to the heatsink. It might all look okay until you switch it on, and then you're going to find out, possibly quite dramatically. Okay, so they're tightened up. So guys, good practice. This is good practice. Multimeter, just make sure it's working. Always do that. Heatsink to the metal tabs. I'm touching the bolt there, okay, but to the metal tab there's no connection. That was the bolt again, no connection. So that's the bolt, which obviously is bolted to the heatsink, but no connection to the tab. No connection to the tab. No connection to the tab. And the last one, no connection to the tab. So that's good to go. So basically now we need to put all this together and see if it actually works. If I've found all of the bad components, it should do. We'll say that much, okay? Unless there was some other previous problem with it before the thing blew up. Let's see if I continue to have some luck. I realised after I'd just put all this back together, there were 4 more resistors down here next to these MOSFETs. So I think they connected the gate. They're all the same value as the other ones we tested, which are these 10 ohm resistors. 2 there, a bit blurred, and one's a bit hidden down here, but the 2 more here. So let's just measure them. Hopefully they're okay and I don't need to unbolt all this again. So I can get down here. One of them is here, and that reads 10 ohms, okay. Another one is down here. Again, I can get at it. That reads 10 ohms. And 2 more, so one here. 10 ohms, and the last one, fingers crossed, 10 ohms. So they're all okay as well. I've put this back together, guys. You can see it's all bolted on here. It's all connected up apart from these. So these are the supplies, plus and minus, and the ground to the amplifier, the HT supply. I don't remember exactly what it was. These capacitors are 80 volts, so plus and minus something less than that, but it could be near to 70 volts. The reason I've not connected this, and I have connected the 15 volt supply, by the way, which goes down to the mixer board, and it also goes onto the amplifier board as well. But the reason I've not connected these in particular is because this is where all the power is going. This is the high voltage and high current. There isn't much load really on these 15 volt supplies. And if I connect these and I power this up and something goes wrong, like it blows up again, for example, I won't know whether the problem is because there's a fault on here causing this to fail or vice versa, although this is the most likely. But it could be a fault on this and just this fails, that doesn't, whatever. But the problem is I don't really know immediately where the problem is. So if I power this up with just the power supply, I'll connect my test meter onto here. If I see the plus and minus supplies, I know this is okay. And then I can connect the main amplifier board and have a look to see if it works, yeah? So let's effectively do it in two halves. We'll put the current limiting light bulb in first, just as an extra safety precaution, and let's see if the power supply works. We see the light bulb over there. I mean, that should come on bright and then go dim or practically off because there's no load on this as such. Let's switch this on now and let's see what it actually does. Oh, well, it went bright and dim and then something went quick and it went bright again. Does the same happen? I've switched it off and switched it back on again. No, it's gone bright again, so something has failed again on this power supply. You hear a little click, there was like a little noise. So here is our power supply again. I'm just checking there's no voltage in the capacitors. I don't really see how there could be. Something failed again on this. Is it the same problem? Are these transistors short or something else? Yep. So those MOSFETs are short again. The only thing I can think here is, firstly, it didn't fail immediately, okay? It didn't fail immediately. It failed after some few seconds. I don't know, either these are just not right, or there's something else on here that I didn't find. So in other words, something else is faulty that I didn't find the first time, and that's what's caused it to fail. That resistor looks a little bit suspect. That one. Is that another one of these 10 ohm resistors? Yeah, but it reads 10 ohms, okay. So I'm going to have to look at this again. Probably do what I did with the amplifier, which is to go through everything to see if I can figure out what went wrong, yeah? Something I just didn't spot the first time. This is that transformer I was mentioning, by the way, which isolates the drive from the actual chip or this lot, which is why I didn't think the failure of those would cause a fault here. But there is some more stuff there that maybe has a problem. You know what I'm going to say, of course, guys, this video is way too long. This is probably going to be another 45-minute video. I'll have a think, because it may be the case that I have to power this up and see if I'm getting the correct drive to the MOSFETs without blowing MOSFETs up. I've got a very good idea how I could do that. You may also have a very good idea, and you know where to comment. So, hey, it's the weekend, guys. It's Friday now, so after the weekend, let's see if we can actually fix this damn thing. Okay, hope you enjoyed that anyway, and I look forward to seeing you all soon on Learning Electronics Repair. Ciao for now, guys.